Welcome to Ask and Learn.
This problem, we have to find out the equivalent impedance. This is the first part of the first part of our problem. So let's calculate it. So first of all, as you can see, this is the value of L, and this is the value of L. This is the value of C. First of all, we have to calculate the value of XL and XC respectively, right? So the formula for and the given in the question it is also given that the value of omega, that is 50 radian per second, right? So first of all, we have to find out the XL, as I already said. So the value of XL, the formula for XL is omega into L. So if I put the values, what I will get is 50 into the L is 10 millihenry. So the value is 10 into 10 to the power of minus 3, right? So this will give 0.5 ohm. The second thing which we have to calculate is this is XL, and we have to calculate is XC. That is, the formula for XC is 1 upon omega C. So what I will get is, if I put the values 50 into, and the value of capacitance C is 10 millifarad. Okay, so 10 into 10 to the power of minus 3. So this will give us 2 ohm, right? Now, as you can see in the circuit, the these two elements are in series, so we can directly get the value of equivalent impedance. So if I redraw the diagram, what I will get is, just I'm redrawing the diagram. So this is our inductance, this is our resistance. What I am going to do is, I'm just putting a equivalent impedance of these two elements. So the value of this is our, I'm just putting the value of XL. So the value of XL, which is value of XL 0.5, and the, if I put in the rectangular form, the value of XL will be 0.5 J, right? This is our 1 ohm, and what we will get from here, let's suppose this is our Z1, right? So Z1 will become, as I write it over here, the Z1 is equal to summation of these two elements, the impedances, or just you can see the real part and the imaginary part. So what we will get the value 1 plus, this is our XC is 2 ohm. This will become, for the capacitance, the sign is negative, right? So this will give us 1 minus 1 minus 2J, right? So this is our value for Z1. So what I will get is, the value of Z1 is 1 minus 2J. For XL, as I see XL 0.5 J. If I write XL in the rectangular form, I'm just writing over here. The value of XL in rectangular form is 0.5 J, and the value of XC in the rectangular form is 2 J. That is in minus, right? So this is a minus 2J. Now what you can see is the 1 ohm resistor and this impedance, both are them in parallel combination. So let's suppose this is the Z equivalent prime. So the value of Z equivalent prime can be written as 1 upon Z equivalent prime is equal to 1 upon the first element, that is 1 upon 1, plus the second one is 1 upon 1 minus 2J, right? So this is our Z equivalent prime. This is not our Z equivalent because XL, as you can see, this XL is still remaining, right? So now let's proceed for further. So the value of 1 upon Z equivalent can be calculated as 1 minus, just simplifying it, 1 minus 2J, 1 minus 2J plus 1, right? So this will become 2 minus 2J upon 1 minus 2J. So if I get the value of Z equivalent prime, this will be 1 minus 2J upon 2 minus 2J, right? So I'm just simplifying it. For the simplifying, what I will get is 1 minus 2J into 2 plus 2J upon 4 square of this and square of this, 4 and 4. So what I will get is, if I just multiply both of them, what I will get is, so if we calculate it or simplify it, you will get the value of Z equivalent dash, that is 3 minus j by 4. Just multiply both of these two terms and divide by 8. You will get the value of Z equivalent prime, right? So this is our Z equivalent prime. And as you can see, if I am again redraw the equivalent circuit, so what I will do is I'm just redrawing the equivalent circuit. The equivalent circuit will be something like this. This is our Z equivalent prime, right? So the value of Z equivalent prime is, as I calculated, this is our 10, sorry, we have to put the value of XL, right? So XL is 0.5 J. So I'm just, yeah. So the value of XL is 0.5 J, and this Z equivalent prime is 3 minus J by 4, right? So now we have to find out the Z equivalent of these two. So these are in series, both of them are in series. So the value of ZIN, which we have to calculate, what we will get is the value of ZIN, just writing it from another color. ZIN will be this XL plus Z equivalent prime, right? This is Z equivalent prime. So what I will get is 0.5 J plus 3 minus J by 4, right? So just simplify both of them. This will give 2J plus 3 minus J by 4, right? So this will give J plus 3 by 4, right? So this is our final answer. And you can also simplify it, more simplify it. What you will get if you simplify, you will get, just calculate it. So you will get the value of, just divide by 4, you will get 0.25 J plus 0.75, right? So the final answer is, this is 0.75. So if I write the answer is ZIN is equal to 0.75 plus 0.25 J, right? This is our final answer. And now move towards the next part of this problem, that is B part. So let's draw the circuit for the B part. So I'm going to draw the circuit for the B1. So this is the diagram for the second part of this problem. So as you can see, we have again the similar question. We have the value of L is given. This is value of, let's suppose this is L1 and this is L2 and this is the C. So the value of L1, L2 and C is given. First of all, similarly, we have to find out the XL1, XL2, XC and then proceed, right? So I'm just finding the value of XL1 first. So XL1 is equal to omega into L1. The value of omega as it is same as in the first one. So this is 50 into the value of L1 is 0.4. So you will get the value of XL1. XL1 is, this is L. So XL1 is 20 ohm, right? So this is our first thing. The second thing is we have to find out the XL2, right? So I'm just calculated the XL2. The XL2 is omega into L2 and the omega is 50 again and the L2 is 0.2, right? So the value of XL2 is 10 ohms. So this is our XL2 and this is our 10 ohm, right? Similarly, we have to find out the XC. So XC, as in the previous problem, the formula for XC is 1 upon omega C and the value of omega is 50 and the value of C is 1 millifarad, right? This is 10 to the power of minus 3. So you will get the value of XC, that is 20 ohms, right? Just put the value of XC. So the value of XC is 20 ohms. So this is our XC, that is 20 ohm, right? Now, if you look at the circuit carefully, you can see these three elements are in parallel, right? So if I make them separately outside from the circuit, what you can see is, so this is our, I'm just drawing that part of the circuit. So this is our XL2, which is XL2 is 10 omega, and in the rectangular form we can write it as 10j, right? And this is our resistor, which is 20, right? Same in the both rectangular as well as simple form, magnitude form. And this is our, oh, need more space, so just clean it up. The value of XL2, I will write it somewhere here, right? So this is XL2. I'm just writing the value of XL2 is, oh, again, just first draw the value of, draw the diagram, and then put the values, right? So this is our C, and the XC value of XC is, value of XC is, as you can see, 20, and if the rectangular form, that will become 20J minus 20J, right? And this is 10J, right? So as you can see, these three are in parallel. So what I can do is, let's suppose the impedance across these three is, again, let's suppose this is our Z1. So if I rewrite the formula, the value of 1 upon Z1 is equal to 1 upon first element, that is resist, that is 20, right? Second one is, this is our inductance, so 1 upon 10j, because we have to write in the whole vector form. This is our vector, right? This is our vector, 1 upon 10j, and the second one is minus 1 upon 20j. This minus is because of this minus, right? As you can see here, the minus, I've just put the minus over here, right? Now if you simplify, what you will get is the value of 1 upon z1. I'm just writing over it. This is the vector, right? Just consider z1 is as vector, right? So just if you simplify, what you will get is 0.05 minus 0.1 j plus 0.05 j, right? So we'll get these values, right? So these are the values of 1 upon z1. So let's further simplify. So value of 1 upon z1 will be 0.05 minus of 0.05 j, right? Just simplify both of them. So this has become value of 1 upon z1. So as we are interested for z1, so let's get the value of z1, get the value of reciprocal of these. So what you will get is the value, I'm just writing it over here. This is 0.051 minus, I just take it out, 0.5 as a factor, right? So this is our 1 upon j, and this is our 1 upon j. So if you simplify, what you will get is, if you take it upside at the numerator, this will give 10, and this will give 1 plus j, right? Just multiply 1 plus j in numerator and denominator, you will get this value, right? So this is our value of z1. Okay, so this is our value of z1 in ohms, right? So if we again look at the circuit, I'm just redrawing the circuit. I just put the equivalent impedance in this place, right? So what will be the circuit look like, right? So the circuit will look like as this. This will our inductor. First is inductor, and the other one, sorry, first one is resistor, right? So I have to redraw it. First one is resistor, and then inductor, and then our Z1. So this is our resistor, this is our inductor, and then our Z1, right? And we have to find out the equivalent of these three. So as you can see, the resistor is 10 ohm, the inductor, we have to put the value of XL, right? So value of XL1, so you can see the value of XL1 is 20, right? So I just putting over here, the value of XL1 is 20, and as you can represent in rectangular form, this will become 20j, right? And the impedance, that we have to calculate it, the z1 is 10 1 plus j, right? So just put over here 10 1 plus j. So all of these are in series, so just add up, right? So the value of z in, or equivalent, or what you can see, just I am writing over here z equivalent. This will be the sum of all these threes, right? This will become 10 plus 20j plus 10 1 plus j, right? So what you will get from over here is 10 plus 20j plus 10 plus 10j. So the final answer is 20 plus 30, right? So the answer will be, I'm just writing the answer will be 20 plus 30j. If you write the unit, that is ohms, right? So this is our final answer for this part also, right? So that's it.